SMT is an application management solution exclusive for SAS applications, which provides functions to monitor and control SAS customer applications. SMT's major functions include real-time monitoring and control, error tracking, dataset leakage prevention, and performance analysis. Let me show you how it works. It has a monitoring menu for real-time monitoring and control, job list menu for error tracking, resource analysis menu for performance analysis, and dataset analysis menu for dataset leakage protection. Now, let me begin the demonstration for each function. First, real-time monitoring and control function. For real-time monitoring and control over SAS applications, SMT shows the status of system resource usage, disk space usage, SAS application and transaction operations, and the job summary thereof. In the job summary, the maximum resource usage by SAS applications for each item and its operation time are shown by total, batch, and online. The system status displays a chart on the resource usage of the server where the SAS applications are currently on. Since the disk status shows the disk space usage which has been mounted on the system in real time, you can prevent disk flow errors in advance. The job list displays the status of batch applications and online processes in real time. If the CPU occupancy rate goes over 50%, it will be signified in red. As such, SMT's monitoring functions enable you to monitor and control SAS applications in real time. Now, let me show you how an online process can be stopped. Out of the online processes running right now, I'll try to stop the EG job process, which is using system resources most. If you find any abnormal batch or online processes, in the pop-up menu, you can select the Stop Current Job menu and click Yes. Then the job will be immediately stopped. Once the job is terminated, you can go to the system status and see the change in resource usage rate. SMT offers real-time management functions for error-free system operation. SMT has an error tracking function for an easy and early detection of errors in batch or online processes. Let me show you how to track errors by clicking the relevant job menu. In the server page, I'll choose the demo server and then open the data of May 6, 2010 for error tracking demonstration. The data shows 8 online processes and 45 batch jobs were executed on that date. Among them, 10 batch jobs had errors. To identify the cause of the errors, in the status column, I'll click the job marked error. In the pop-up menu, I'll use the View Detail menu. To make it easier to learn about the execution structure of applications, the detailed view page presents information on all execution steps in a code tree view. If an error occurs on a step, the line number on the error will be marked in red in the SAS log line column. To find out the source code of the step with an error, let me double-click the relevant step. After double-clicking the step, the source code will be loaded in the source page, and the focus will automatically move to the error spot. Using this method, you can easily view the details of source code errors. But if you want to identify more accurate cause of the errors through the SAS log file, you can select the relevant step and click the View Log in the pop-up menu. If you click the View Log menu, the log file that has SAS created will be loaded in the Log tab, and then the focus will automatically move to the error spot, allowing you to check both source and error details. As such, SMT provides a function that can dramatically save time to figure out the cause of SAS application errors. SMT offers a data leakage protection function by managing information on dataset access by SAS batch applications or online processes. Let me click the Dataset Analysis menu first. Like I did earlier, I will select the demo server from the server page and open the data of May 6, 2010 for demonstration. As of May 6, 2010, a total of 22 datasets were used by SAS applications. Let me analyze the access record for the dataset with the highest access. When you double-click the Scenario 1 dataset, it will show the SAS applications separately by batch and by online process. At the root of the code tree, server login user IDs will appear. In the batch section, the batch applications that use the Scenario 1 dataset will be listed, and you can analyze each batch application using the job detail view page in the same way we did in the error tracking part. In the online section, the online processes that use the Scenario 1 dataset will be listed by user, and each user's user ID and IP address will enable you to analyze who and when access the dataset through what kind of job processes. The job detail view page is also available for online processes. As such, SMT offers data leakage protection that prevents important information from leaking. SMT has a function that enables efficient system operation through performance analysis of SAS batch applications or online processes. Let me select the Resource Analysis menu. As seen earlier, I will select the demo server from the server page and load the data of May 6, 2010. From the system status chart, I will choose the sections with high resource usage by time frame. These are the sections where SAS applications use a lot of system resources. Now let me drag one of those sections. I'll try to look up which processes were used in the selected section. What you're seeing right now is the list of the processes operated in the section. The system shows the resource usage by the entire system, while the SAS shows resource usage by SAS applications. It looks similar to each monitoring page of the process list, but to analyze the process that gave much load to the system, eCPU and eMemory columns were additionally added. eCPU and eMemory are the time-weighted usage rates of CPU and memory respectively. Let me now select the job with the highest eCPU. You can see that the highest eCPU came from the job done at this IP address by this user ID using EG at 9:18. If you click the job in the system status chart, you can review the resource usage of the relevant time frame. If you want to know why this job used so much system resources, you can use the job detail view page. As such, SMT supports stable system operation by optimizing SAS applications. With this, I'll conclude the SMT demonstration. Thank you.